Hi, this is the video for Lab 8. So right now I'm going to show you part B, which was just our Schmidt trigger. So we have two sets of op amps here. This op amp is the actual trigger. This is both giving us our reference voltage through a voltage follower and a divider, and also providing our 0 to 10 volt input signal by just creating an amplifier. So the way the Schmidt trigger actually works is the most important thing are these resistor values here. So we knew our V rails because we measured it before following the lab instructions. So we knew what our V rails were going to be just based on the values of the op amp. So we had to determine what our resistors had to be in order to get the trigger voltages to be 7 volts and 3 volts respectively. So that's what this setup here is doing. And then what you get, you have a 0 to 10 volt input wave, and then as this rises to 7 volts, the Schmidt trigger will lower to its negative rail, and when it goes below 3 volts, it will rise to its positive rail. And this is useful because it basically lets you avoid noise in the circuit. So like any noise affecting your input wave wouldn't really affect this output here unless it was like a very drastic amount of noise. For part A, we made a current source using a potentiometer, an op amp, and a transistor. Essentially, the purpose of this is just to control the current. So in this case, as you increase the voltage out of the potentiometer, you're going to decrease the collector current, which is what we were measuring across. So we measured V in, which is at this red wire here relative to ground, and then the current out of the collector, which is the far right pin on the transistor. And this is just one component of part C. So, and just to illustrate this in the form of like a graph, as it's a linear relationship, and as we increase the voltage, we decrease the output current. So hopefully I'll be able to explain this in more detail in the report, but basically what happened, I started Lab C with my partner Nick, but we almost finished it, but not quite. Like, we didn't start collecting our data. We almost had the circuit work with maybe a little bit more debugging. Nick finished it on Friday, but I'm not in his section, so here I am trying to finish it now. But unfortunately, I had to completely rebuild it, and for some reason, I've tried like everything. I've been here a few hours. I just can't seem to get this to work. So I'm gonna try again tomorrow, but for right now, the best I have is just kind of a overview of what I tried to make. I assume like some of the connections must just not be right, but I really don't know. Sometimes there was a time when I was getting like the sawtooth waveform, although the V1 and V2 values weren't what I was expecting. But right now I'm getting this, which is not at all what I would expect. I seem to be having issues with the input as well, because you see I'm about to take off channel 2 or channel 1, so the yellow, and even though it's not connected to anything right now, it's still changing based on like what the other channel is doing. So I don't know if maybe there's some inaccuracy based on that or what's causing that. But hopefully this won't be the video I submit. Hopefully I'll figure